Good day class, I am Ma'am J and I'm here again to teach you another topic which is related to factoring. Is everybody ready to start? I think we can start now, so let's begin.
Factoring polynomial with difference of two cubes. DOTC for short. So let's have a review. So factor completely. So let's have a short recap on how to factor out sum of two cubes. So let's have number 1, x cubed plus 1000. Solution. Check if it is a binomial with positive sign in between terms and both of the first and last term has cube root. Since our given is a sum of two cubes, so we can use the pattern quantity a plus b times quantity a squared minus ab plus b squared. So step 1, take the cube root of the first and last term. Our first term is equals to x cubed, so the cube root of x cubed is equals to x. Our last term is equals to 1000, so the cube root of 1000 is equals to 10. Step 2, substitute the given cube root of the first and last term in the pattern. So we have a equals to x and b equals to 10. So quantity x plus 10 times quantity x squared minus 10x plus 10 raised to 2, which is equals to 100. So the factored form of x cubed plus 1000 is equals to quantity x plus 10 times quantity x squared minus 10x plus 100. Number 2, x cubed plus 512. Solution. Check if it is a binomial with positive sign in between terms and both of the first and last term has cube root. So we can now use the pattern. Quantity a plus b times quantity a squared minus ab plus b squared. So step 1, take the cube root of the first and last term. So our first term is equals to x cubed. So the cube root of x cubed is equals to x. Our last term is 512. So the cube root of 512 is equals to 8. Step 2, substitute the given cube root of the first and last term in the pattern. So we have a equals to x and b equals to 8. So quantity x plus 8 times x squared minus 8x plus 8 raised to 2 or equals to 64. So the factor form of x cubed plus 512 is equals to quantity x plus 8 times quantity x squared minus 8x plus 64. Number 3, x cubed plus 75. Solution. Check if it is a binomial with positive sign in between terms and both of the first and last term has cube root. So check, it is a binomial, it has a positive sign in between two terms, but the last term of the binomial, which is 75, has no cube root. So our answer is not factorable. So x cubed plus 75 is not factorable since the last term of the binomial, which is 75, has no cube root. Number 4, 8x cubed plus 27. Solution. Always check if it is a binomial with positive sign in between terms and both of the first and last term has cube root. So you can use the pattern quantity a plus b times quantity a squared minus ab plus b squared. So step 1, take the cube root of the first and last term. So our first term is equals to 8x cubed. So the cube root of 8x cubed is equals to 2x. Our last term is equals to 27. So the cube root of 27 is equals to 3. Step 2, substitute the given cube root of the first and last term in the pattern. So a equals to 2x and b equals to 3. So quantity 2x plus 3 times quantity 2x raised to 2, which is equals to 4x squared, minus 2x times 3, which is equals to negative 6x, plus 3 raised to 2, which is equals to 9. So the factor form of 8x cubed plus 27 is equals to quantity 2x plus 3 times quantity 4x squared minus 6x plus 9. Number 5. 729x cubed plus 64y cubed. Solution. So check if it is a binomial with positive sign in between terms and both of the first and last term has cube root. So we can now use the pattern. So step 1, take the cube root of the first and last term. So our first term is equals to 729x cubed. So the cube root of 729x cubed is equals to 9x. Our last term is equals to 64y cubed. So the cube root of 64y raised to 3 is equals to 4y. Step 2, substitute the given cube root of the first and last term in the pattern. So we have a equals to 9x and b equals to 4y. So quantity 9x plus 4y times quantity 9x squared, which is equals to 81x squared, minus 9x times 4y equals negative 36xy, plus 4y raised to 2 is equals to 16y squared. So the factored form of 729x cubed plus 64y cubed is equals to quantity 9x plus 4y times quantity 81x squared minus 36xy plus 16y squared. The difference of two cubes is a special case in multiplying polynomials. Quantity a minus b times quantity a squared plus ab plus b squared is equals to a cubed minus b cubed. It comes up sometimes when solving things, so it's worth remembering. And this is why it works out so simply. So when we multiply quantity a minus b to quantity a squared plus ab plus b squared, we have, so using the distributive property, we have a times a squared is equals to a cubed, a times ab is equals to positive a squared b, a times b squared is equals to positive ab squared, a squared times negative b is equals to negative a squared b, ab times negative b is equals to negative ab squared, and positive b squared times negative b is equals to negative b cubed. So cancel out the middle term and the remaining answer will be a cubed minus b cubed. Factoring out the difference of two cubes is the reverse of multiplying a polynomials in the form quantity a minus b times quantity a squared plus ab plus b squared. So remember, 1, 8, 27, 64, 125, 216, 343, 512, 729, 1000, so on and so forth are all perfect cubes numbers. So steps in factoring polynomial with difference of two cubes. So we can only use the pattern quantity a cubed minus b cubed is equals to quantity a minus b times quantity a squared plus ab plus b squared. First, notice that there are three requirements that must be met in order for us to be able to use this pattern. So number 1, it must be a binomial, so have two terms. Number 2, both terms must be a perfect cube, so meaning that you can take the cube root. And number 3, there must be a subtraction, negative sign, not addition in between them. So if these three requirements are met, then we can easily factor the binomial using the pattern. So simply number 1, take the cube root of the first and last term. Number 2, substitute the given cube root of the first term in A and cube root of the last term in B in the pattern. So same method with the sum of two cubes. Examples. Number 1, x cubed minus 216. Solution. So check if it has satisfied the three requirements. Since it is yes, so we can now use the pattern quantity a minus b times quantity a squared plus ab plus b squared. So step 1, take the cube root of the first and last term. Our first term is equals to x cubed, so the cube root of x cubed is equals to x. Our last term is equals to 216, so the cube root of 216 is equals to 6. Step 2, substitute the given cube root of the first and last term in the pattern. So a equals to x and b equals to 6. So we have quantity x minus 6 times quantity x squared plus 6x plus 6 raised to 2 or equals to 36. So the factor form of x cubed minus 216 is equals to quantity x minus 6 times quantity x squared plus 6x plus 36. Checking. Let's check if x cubed minus 216 is equals to quantity x minus 6 times quantity x squared plus 6x plus 36. So using distributive property, we will multiply x times x squared, which is equals to x cubed, x times 6x, which is equals to 6x squared, x times 36, which is equals to 36x, negative 6 times x squared equals negative 6x squared, negative 6 times 6x equals negative 36x, and negative 6 times 36, which is equals to negative 216. Cancel the two common terms with different sign, which is equals to 0, then x cubed minus 216. So the remaining answer is x cubed minus 216. So our answer is correct. Number 2, x cubed minus 343. Solution. Check if it is satisfied the three requirements. Since it is yes, so we can now use the pattern quantity a minus b times quantity a squared plus ab plus b squared. So step 1, take the cube root of the first and last term. So our first term is equals to x cubed, so the cube root of x cubed is equals to x. Our last term is equals to 343, so the cube root of 343 is equals to 7. Step 2, substitute the given cube root of the first and last term in the pattern. So we have a equals to x and b equals to 7. So quantity x minus 7 times quantity x squared plus 7x plus 7 raised to 2, which is equals to 49. So the factor form of x cubed minus 343 is equals to quantity x minus 7 times quantity x squared plus 7x plus 49. Checking. X cubed minus 343 has a factor form of quantity x minus 7 times quantity x squared plus 7x plus 49. Let's check if it is true. So let's multiply. X times x squared is equals to x cubed. X times 7x is equals to 7x squared. X times 49 is equals to 49x. Negative 7 times x squared equals negative 7x squared. Negative 7 times 7x equals negative 49x. And negative 7 times 49 is equals to negative 343. So cancel the middle term since it is equals to 0. So the remaining answer is x cubed minus 343. So our answer is correct. Number 3, x cubed minus 7. Solution. So check if it is satisfied the three requirements. So check. It is a binomial. It has a negative sign in between two terms. But the last term of the binomial, which is 7, has no cube root. So x cubed minus 7 is not factorable. So our answer is not factorable since the last term of the binomial, which is 7, has no cube root. Number 4. 64x cubed minus 729. Solution. Check if it is satisfied the three requirements. Since it is yes, so we can now use the pattern. So step 1, take the cube root of the first and last term. So our first term is equals to 64x cubed. So the square root of 64x cubed is equals to 4x. Our last term is equals to 729. So the cube root of 729 is equals to 9. Step 2, substitute the given cube root of the first and last term in the pattern. So A equals to 4x and B equals to 9. So quantity 4x minus 9 times quantity 4x squared, which is equals to 16x squared, plus 4x times 9, which is equals to 36x, plus 9 raised to 2, which is equals to 81. So the factor form of 64x cubed minus 729 is equals to quantity 4x minus 9 times quantity 16x squared plus 36x plus 81. Checking. So 64x cubed minus 729. Let's check if it is equals to quantity 4x minus 9 times quantity 16x squared plus 36x plus 81. So apply the distributive property. So we have 4x times 16x squared equals 64x cubed. 4x times 36x equals 144x squared. 4x times 81 equals 324x. Negative 9 times 16x squared equals negative 144x squared. Negative 9 times 36x equals negative 324x. And negative 9 times 81 equals negative 729. So cancel out the middle term. So the remaining answer is equals to 64x cubed minus 729. So our answer is correct. Number 5. 729x cubed minus 64y cubed. Solution. So check if it is satisfied the three requirements. Since it is yes, so we can now use the pattern. So step 1, take the cube root of the first and last term. So our first term is equals to 729x cubed. So the cube root of 729x cubed is equals to 9x. Our last term is equals to 64y cubed. So the cube root of 64y cubed is equals to 4y. Step 2, substitute the given cube root of the first and last term in the pattern. So we have A equals to 9x and B equals to 4y. So quantity 9x minus 4y times quantity 9x squared, which is equals to 81x squared, plus 9x times 4y, which is equals to 36xy, plus 4y raised to 2, which is equals to 16y squared. So the factor form of 729x cubed minus 64y cubed is equals to quantity 9x minus 4y times quantity 81x squared plus 36xy plus 16y squared. Let's check if 729x cubed minus 64y cubed is equals to quantity 9x minus 4y times quantity 81x squared plus 36xy plus 16y squared. So using distributive property, we have 9x times 81x squared is equals to 729x cubed. 9x times 36xy is equals to 324x squared y. 9x times 16y squared is equals to 144xy squared. Negative 4y times 81x squared is equals to negative 324x squared y. Negative 4y times 36xy is equals to negative 144xy squared. And negative 4y times 16y squared is equals to negative 64y cubed. So cancel the middle term. So the remaining answer will be 729x cubed minus 64y cubed. So our answer is correct. So let's have an activity. So factored completely. And for your assignment, so factor completely. That's all for today. Thank you for watching. If this video is a great help to you, then please don't forget to like, share, and of course, subscribe to my channel. Thanks!